The next method that we're going to talk about for systems of equations is called substitution. Substitution is more of an algebraic method to solve a system. We're not going to be graphing these equations. We're going to use one of the equations. We're going to solve one equation for one variable and plug that into the other equation to find our solution. Okay, so we have 5 steps here we're going to look at when solving an equation with substitution. Step 1 says solve one equation for one variable. Okay, so we're going to pick the easier equation. The goal is to get y equals or x equals a equals something. We're going to get y equals, maybe mx plus b, something with that looks like slope-intercept form. We could also solve for x and get x equals 4y plus 8, something like that. And we're going to take that expression that x or y is equal to, and we're going to substitute that expression into the other equation. Okay, so it's going to make a little more sense here in just a minute when we look at some examples. Okay, but we put the equation solved in step 1 into the other equation. Then we're going to solve, and we'll get a variable by itself. So at this point, we will have either x equals a number or y equals a number. So we will take this number and we'll plug it into the other equation. And then at that point, we will have both an x and a y. And then step 5 is just us checking our solution. Okay, so like I said, might not make a ton of sense just yet, but when we look at our examples, it'll make a little more sense. Okay, so once again, there are 3 solutions that we could get. One solution, no solution, and infinitely many solutions. On graphs, it's a lot easier to see these solutions because we know one solution, we have intersecting lines, no solution is parallel lines, and infinitely many solutions is the same line. However, when we're solving algebraically, we don't have the luxury of being able to just look at the graph and see. So we're going to have to interpret these answers just a little bit. All right, so remember, for one solution, we're going to finish with an exact ordered pair. So that's going to be the easiest answer to see. We're going to get x equals a number, and we're going to also get y equals a number. So we'll get x equals 5, x equals 0, x equals -2, y equals 3, y equals 7, some kind of number for x and y that we could put together and create an ordered pair. That's when we have one solution. So we'll see an example of that in just a minute. When our answer is no solution, we're going to finish with something that does not make sense, right? So our variables are going to eliminate, our x's will disappear, our y's will disappear, and we'll be left with something like 3 equals 7 or 0 equals 5. Those statements are not true. They don't make sense. 3 is not equal to 7, 0 is not equal to 5. So in that case, there is no solution. There's nothing that works for those equations. Infinitely many is similar to no solution, but we will finish with something that does make sense. So we'll get 0 equals 0, 9 equals 9, -3 equals -3, 8x equals 8x, -4y equals -4y. There's endless examples that we could see that would show us if we have infinitely many solutions. Okay, so I have an example down here. We're actually going to come back to that in just a moment. But we're going to look at 3 examples here. We're going to use substitution in all 3 of these examples, and we will have one type of solution for each example. All right, so let's look at example number 1. And I like to work vertically here. One of the keys to substitution is being organized, because there's going to be a lot of work, and we got to make sure we keep everything organized so we know where to find certain pieces of information. All right, so if we look here, we have y equals 6x minus 11 and -2x minus 3y equals -7. Okay, so we're looking for an equation that has y equals or has x equals. So in this case, we're going to start off with our first equation. We have y equals 6x minus 11. So we already know what y is equal to. Y is equal to 6x minus 11. And remember, this is a system. So whatever y is equal to in the first equation, y has to also be equal to that in the second equation. So since y is equal to 6x minus 11, I could take this entire equation, this entire expression, and plug it in right there for y, and I can solve for x. So let's do that. So we have -2x minus 3, and now instead of y, I'm going to plug in 6x minus 11 equals -7. So we just substituted 6x minus 11 in for y, in the second equation. So now we solve here. So we say negative 2x minus, and we distribute. So this is 18x, because negative 3 times 6x. Negative 3 times negative 11 would be plus 33, and that equals negative 7. Okay, so now we're going to look and just combine some like terms here. So we have negative 2x minus 18x. So we have negative 20x plus 33 equals negative 7. Subtract 33 from both sides, and we get negative 20x equals negative 40. Divide both sides by negative 20, and we get x equals 2. And at this point, we are halfway there, because remember, we're trying to find what x is equal to and what y is equal to. I say we're halfway, but really we're a majority of the way done because we've done most of the work. So now we're going to take x equals 2, and we're going to plug it back into either this equation or this equation to solve for y. I would prefer the first one because it looks a little easier. So now I take y equals 6, and now instead of x, I write 2 because x is equal to 2, minus 11. So we get y equals 12 minus 11, and we get y equals 1. So my final answer, I would say, is 2, 1, because I'm trying to write it as an ordered pair. And we would say that there is one solution. That solution is 2, 1. Example number 2, we have negative 3x plus 3y equals 4, and negative x plus y equals 3. So unlike example 1, we don't have one of our equations that's already solved for one of the variables. So we're going to choose one and solve it for one of the variables. I'm going to choose the second one because I don't have to deal with the coefficients of 3 in the first equation. I'm going to solve for y because all I have to do here is add x to both sides, and I get y equals x plus 3. Or I could say 3 plus x, it doesn't matter. So now I'm going to take this expression, x plus 3, and I'm going to plug it in all the way right there into my other equation that I have not touched yet. So now I rewrite that equation, negative 3x plus 3, and now I write x plus 3 into my equation for y, and that is equal to 4. Now I solve. Negative 3x plus 3x plus 9 equals 4, and I combine like terms. Well, what happens here? What's negative 3x plus 3x? Well, that's 0, right? They cancel out. So those cancel. So I'm left with 9 equals 4. Is it a true statement? No, it is not. So we would be done at this point. We would write there is no solution because 9 does not equal 4. And we're done. So in that case, there's a little less work for us to do. So if we notice there what happened, our x's canceled each other out, and we were left with something that did not make sense. So our solution is no solution. The last one we're going to look at says negative, or on this page, negative 12x minus 15y equals negative 9, and 4x plus 5y equals 3. So in this case, it might not be a clear choice as to which equation to solve, but I'm going to go ahead and solve the second one. And let's solve the second equation for x, since we've solved for y in the first two equations. Okay, so if I want to solve for x, I'm going to try and get x equals. So I'm going to subtract 5y, so I get 4x equals 5y plus 3. Okay, so I'm going to divide all three parts by 4, and I get x equals 5 over 4y plus 3 over 4. And, you know, I know that's kind of tricky with fractions in there, so I could use those fractions if I want, or I could change them to decimals. Either way, I'm going to get the same thing. So that's what x is equal to. So I'm going to take my equation I have not touched yet, which is this first one, and I'm going to plug this expression in for x right there. Okay, so I'm going to rewrite my first equation, negative 12, but now instead of writing x, I'm going to write what x is equal to, 5 over 4y plus 3 over 4. Then we have minus 15y equals negative 9. Okay, so here we have a negative times a positive, so we're going to have a negative. And remember we talked about multiplying fractions, right? So we could do 12 times 5, which is 60, divided by 4, which is 15, or we could think 12 divided by 4, which is 3, 3 times 5, 15. So this is negative 15y. Once again, a negative times a positive, so we have minus. 12 times 3 is 36. 36 divided by 4 is 9. Or we could do 12 divided by 4, which is 3. 3 times 3, which is 9. So we have negative 15y minus 9 minus 15y equals negative 9. Okay? All right. So now we're going to look and we're going to combine some like terms here. And I think I wrote my equation down wrong. This was a negative. So we have negative times a negative. So this should be a negative here. I think I wrote my equation down wrong. So this is going to give us a positive 15. My apologies. So now we combine our like terms, and we get negative 15y plus 15y, and those cancel out. So we're left with negative 9 equals negative 9. And that is a true statement, right? Negative 9 is equal to negative 9. So we would say that there are infinitely many solutions. Okay, so there's our 3 types of solutions. First one, we got x equals 2, so we could plug 2 into our other equation. We got y equals 1. So we have a solution of 2, 1. Number 2, our x is canceled out, so we're left with 9 equals 4, and that did not make sense. So that's no solution. And example 3, our negative 15y and positive 15y canceled out, and we were left with negative 9 equals negative 9, which is a true statement, so that's infinitely many solutions. The last example we're going to look at is a word problem, and our word problem has some examples at the bottom, and we're on the last example, which says Mr. Roper has quarters and dimes in his pocket. He has a total of 9 coins. If the amount of money he has is $1.80, how many of each coin does he have? So we're going to have to write 2 equations here, and we're going to have to solve the 2 equations to figure out how many quarters and dimes we have, okay? So it says we have 9 coins, and we have quarters and dimes. So we could say that this is Q, and this is D for dimes. And we're going to write an equation for the number of coins that I have, okay? So we could say that Q plus D equals 9. We know that there are 9 coins in total. We don't know exactly how many quarters there are, how many dimes there are, but we do know there are 9 coins. Okay, so now it says if the amount of money is $1.80, how many of each coin does he have? Okay, well now we're going to write an equation in terms of money. So we got to think about quarters. How would we write quarters in terms of money? Well, a quarter is 25 cents, right? So we would say 0.25Q plus dimes are 10 cents equals $1.80. So think about when we had equations with decimals. What's going to make this easier for us? Well, to get rid of the decimals, right? So what do I have to do to make each of these numbers a whole number? I got to move the decimal 1, 2, 1, 2, 1, 2. So this equation I could say is 25Q plus 10D equals 180. My first equation, I just have Q plus D equals 9. So I'm going to use substitution to solve this problem. So my first equation is going to be a whole lot easier to solve, and I'm going to solve for D. Okay, so I'm going to subtract Q from both sides. So this equation is D equals 9 minus Q, or negative Q plus 9, either way. So this is my expression that I'm going to plug in right there. Okay, so I get 25Q plus 10 times 9 minus Q equals 180. So from here, we can bring down the 25Q, distribute here, plus 90 equals negative 10Q, or minus 10Q equals 180. So we plugged in 9 minus Q, 25Q plus 90 minus 10Q equals 180. Combine some like terms here. 25Q minus 10Q gives me 15Q plus 90 equals 180. Subtract 90 from both sides. We'll move over here. So we get 15Q equals 90. And we divide both sides by 15, and we get Q equals 6. So we know we have 6 quarters. Okay, so now at this point, if we have 6 quarters and we have 9 total coins, that means we're gonna have 3 dimes. Okay, so how can we check this? Well, we know that 6 quarters would be, 4 quarters is $1, so 2 more would be $1.50. 3 dimes would be 30 cents. If we add those together, we get $1.80. So this is the method of substitution.